All right. Well, anyway, thanks for the introduction, Russ, and thanks for having me. Thanks everyone for being here. Today, I'm going to talk about CodaLab Worksheets, which is this platform that my group has been building for the last 8 years or so to enable reproducibility and help researchers go faster. So there's two problems I want to point out with the current research process. The first is around reproducibility. So here's a typical paper you read. There's an incumbent method that has a certain type of accuracy, and the paper proposes a new method and demonstrate that there's some gains in accuracy. But maybe this is only for one data set. If you're lucky, maybe there's multiple data sets. But what about all the other kind of possible data sets? Does a new method actually systematically provide improvements over the incumbent? So I kind of liken to the state of affairs as kind of how people thought about the world around 1500. You just have a kind of very incomplete and sometimes inaccurate view of what's happening. I want to point out also that reproducibility, there's kind of two notions here. One is the narrower replicability, which is if you ran this new method again, are you going to get 92% accuracy? And then generalizability, which has to do with how generalizable are these gains to other novel settings. So that's the first problem, is reproducibility. The second problem is efficiency. So you come up with a brilliant idea. That's step one. And what do you have to do to execute on it? Well, you have to, in any sort of kind of computational or modeling project, you have to get some data, clean it, convert it between formats, munge it. You might want to reproduce some results from previous work. If those don't work, you email the authors, you run experiments with different versions because you want to try different things out. And now you have to do all this bookkeeping to keep track of what data and code belonged to which experiment. And soon you're kind of just in this situation where it's kind of a total mess. Now, these two desiderata of efficiency and reproducibility. So there's kind of conventional wisdom that reproducibility will slow you down. Reproducibility seems hard. You have to do even more work than you were able to do. And how is that going to help you with efficiency? And what I want to argue in this talk is that reproducibility is actually a way of accelerating research, and it provided you have the right tool. And I'll try to argue how CodaLab provides you with the right tool for doing this. So the story starts back in actually 2008. This is when I was in grad school at Berkeley. I developed a platform called MLComp. And the idea was you would upload an ML algorithm, you would upload a data set, and you would be able to run any ML algorithm on any data set, and you get some sort of accuracy metrics. So the nice thing about MLComp was that it was very simple as a kind of a conceptual model. The bad thing about MLComp was that it was very simple because researchers often have new forms of interaction, new different pipelines. It didn't really fit the MLComp mold. It doesn't really help you with this efficiency bit. It may help you with reproducibility. So then in 2013, when I came to Stanford, we decided to kind of give it a reboot and develop CodaLab Worksheets, was meant to be a much more flexible platform that could both give you reproducibility and efficiency. So let me describe CodaLab Worksheets, the kind of the conceptual underpinnings, and I'm going to give you a demo so you can kind of get a sense of how it works in practice. So there's two concepts in CodaLab Worksheets, bundles and worksheets. So a bundle is an arbitrary file or directory. This bundle could contain code or data or results or a model. And each bundle is going to be depicted, one of these pills, has a unique UID, its ID, which means that it kind of snapshots a particular version of this asset. So you can always refer to this bundle and people know unambiguously what you're talking about. So bundles can be uploaded to the system by the user. So you upload code or data, or they can be derived by running an arbitrary command. So let me give you an example of how this works. So here is a bundle. It's a simple Python file that implements a convolutional neural network, let's say. Here's another bundle. It's a directory that contains the MNIST data set. And here is a third bundle, which is a run bundle. So these two are uploaded. This is a run bundle that's derived from running a command with these two other bundles as dependencies. And the way that the contents of this bundle are going to be filled out is as follows. So given this structure here, we're going to create a temporary environment using a Docker image. And we're going to essentially copy or mount these dependencies into a temporary directory. So C with the names given by this edges. So cnn.py is represented here, and it will point to the contents of this bundle. The data is a directory that is going to point to the contents of this bundle. And then you just run this command that's associated with this bundle. It can be an arbitrary command. You can use Python. You can use C++, Ruby, whatever. And in the process of running this command, it will output some files. And the files are what's copied back to represent the contents of this bundle. So it's a little bit like kind of functional programming, where this is a kind of temporary state used for the computation, and then this Docker image container is thrown out. And all that's left is the output of running this command on these bundles. Now, once you have this bundle, now this behaves just like another bundle, and you can use it downstream to do error analysis, to ensemble models, or whatever. So, so that's, in a nutshell, all there is to how bundles work. Bundles are nodes in a graph, and there's kind of root nodes, which are uploaded by the users, and intermediate nodes, which are created by running arbitrary commands in Docker containers. So how do you actually interact with the system? We have a command line interface, a CLI, which you can use just to give you a flavor of what types of things you can do with a system. You could search existing bundles, code, or data. You can upload new code or data. You can run experiments. I'll show more of this in a bit using CLRun. You can look at the output of runs, CLCat. You can manage runs, so bundles could be running and you can kill them before they're done. You can remove them. And there's this kind of really cool feature called Mimic, which I'll talk a little bit more about, which is one of the most kind of powerful features of CodaLab, which allows you to kind of replicate an entire pipeline. So if you have a new version of the code or data set, you can just mimic whatever you did with the existing code or data set and run it on the new one. And there's a notion of kind of you have different CodaLab instances which you can copy between. So stepping back a little bit, why is this kind of bundle graph, I guess, the right way to think about progress in the community? Real world problems require efforts of a whole community, right? So people specialize. Some people develop model architecture, some people create data sets. So in effect, everyone's kind of contributing in some decentralized way. So you can think about the CodaLab bundle graph as a kind of a concrete way of encapsulating what is already happening in the community. So you can think about each person kind of creating different bundles by running experiments in a kind of decentralized way. And then one thing that's interesting about if you are able to capture this research process in this kind of formulaic way, you can now ask all sorts of interesting questions. So imagine you have an intermediate node here. So this represents, let's say, a pre-trained language model. And you want to say, how good is this language model? So normally you would, you would argue maybe based on some sort of metrics that you come up with. But with the graph, you can actually see concretely what happens. So if you have a newer language model, you can just plug it in and you can run the entire pipeline downstream, because we know exactly what commands were run downstream of that model and what analyses were run. So you can basically swap this in and you can see, and you can compare the two results. And if you want to modify this bundle, you can do the same. So one slight correction is that we don't actually modify anything, because then it would be kind of crazy. Things are actually immutable, and the inspiration here is Git version control. So all these programs, data sets, and runs are write once. You create a bundle, it's immutable, it doesn't change. And this enables collaboration without chaos because you're only adding to this graph. This captures the research process in a reproducible way. So how Mimic was implemented is actually creating a second copy and not replacing the old one, but just creating a copy. Okay, so that's the bundle graph. Let me talk about worksheets. So bundle graphs are really about kind of truth. What computations were run and what are the results? But how do you interpret these results? And this is where worksheets come in. A worksheet is an arbitrary document with embedded bundles. And the inspiration is taken from Jupyter Notebook, Mathematical Notebook, CodaLab more recently now. And this is what a CodaLab Worksheets looks like. There's some text, and here inside you have embedded a bundle. As you will show later, that bundles can actually be rendered in a custom Markdown language to create plots, tables, and so on. But behind all of this is a bundle graph. So you have a bundle graph, which is just a global graph that represents all the computation that was done in the system. And then you have these views. Worksheets are views on top of the bundle graph that users will look at to interact with the system. So there's a custom Markdown language that allows you to use arbitrary Markdown and embed bundles. You can have some directives that tell you how to display the bundle contents. You can define custom schemas to visualize results in a table, graph points. And you can actually have this really powerful primitive that embeds like a search operator to make a custom table based on some parameters. There's a bunch of, you can think about CodaLab as really a kind of a general platform. It's kind of an operating system for kind of reproducible research in some sense. So there's a number of use cases, and I want to highlight some of them to just give me an idea of how it works. So executable papers. This is one of the kind of early motivations for creating CodaLab along the idea of reproducibility. So here the idea is right now, not that you would replace your PDF paper, but eventually maybe, but that this would be kind of an extended appendix that shows you how the actual experiments in your paper were produced. So this table, for example, is actually created from a bundle, and you can look into it and you can know exactly what code produced it, what data produced it. And we've been doing, putting all our papers in my group on CodaLab for the last 6 years or so. Another thing you could do is benchmark results. We'll talk a little bit about this later. You can have leaderboards where you have standard data sets and people can submit predictions or code, and you can run them. And the third use case is as a research development environment. So the idea here, this has to do with the efficiency thrust that I talked about earlier. This CodaLab is meant to help you just be a more efficient researcher by managing your runs. You can upload code, data, launch a bunch of runs, and have the backend figure out where to run them and how, so you never have to go and copy files kind of manually, and you can kind of view them from the comfort of your a website. So let me now give a demo of CodaLab just to give you an idea of how this works. So if you go to CodaLabWorksheets.org, so I'm logged in, but here you have the main site. If you're logged in, you get to see basically your profile. This has your worksheets. I'm going to create a new worksheet. Let's call it PM demo. So now this is just a blank page. I can call this, let's say, CORES demo. And you can add text. Hello, I'm going to do some sentiment classification today. And then you can upload bundles. So you can do an upload. We have this text class.py. It's a simple Python program that implements stochastic gradient descent on a linear classifier. And here it is. By default, bundles are rendered as a table. Each bundle has a unique UID. as I described before. The name, it has a name, which is, you can change it. It doesn't have to be, it doesn't have to be unique. It has a size and a state. Ready means that it's ready to go. You can look at its contents, you can download it, and so on. You can also selectively give permissions to people. Okay, so that's the one bundle. Let me upload 2 more bundles. So here's a data set for sentiment classification. There's 2 files, a train file and a test file. And there we have them. So you can take a look. These are the contents. So you have the label and a review. We're doing binary classification on reviews. Okay, so now let's see. Now I'm going to run a command. So let me just, one thing I like to do is running a baseline. Let's do this. So I like to kind of document what I'm doing as I go along. So you can do a run. So now when I do a run, remember a run is just creating a bundle, and I have to specify the dependencies. Now this is a little bit of a kind of a gotcha with CodaLab users, is you have to be explicit about what dependencies you're gonna need, because remember, this is a whole, there's all these bundles in this, in the system, and we need to know which ones to kind of copy to the worker machine. So I'm going to have 3 dependencies here, and then I'm going to run a command, text class train polarity.train. So as if I have these 3 files in the current directory. So polarity.test. Okay, so that's the command, and here I can modify some metadata, specify what resources, how much disk space, memory, CPUs. I can support GPUs too, and so on. So I'm going to hit enter, and this creates a bundle. Notice its state is created, and now it's preparing, which means that the backend notice that, hey, I have this job that I need to go and run somewhere. And you'll see that preparing means that it's kind of setting it up on the worker, and hopefully it will be running now. Now it's running, and you can see all the metadata. So here's the command. Here is now the run just created some files here, and you can see the dependencies. And now it's uploading results. It was a fast run. And hopefully we'll see what happened here. Okay. Let's see. So it's, well, let me not, okay. So here's the output. So it just outputted some, accuracies as it was training. So one thing I want to point out is you can also do this from command line interface, which I'll demonstrate. So depending on your preferred mode of operation, let's see. So the way to do this is so a worksheet has a name. So okay, let me start over. So you pip install CodaLab. This will give you access to a CLI. It's called CL. And then I can do CL work, which is like switching a worksheet. I can switch to PLAN demo, which is the name of this worksheet. And then I'm on this worksheet and I can run commands. So let me run. I'm just going to show you how I can do the same thing from the command line. So I specify dependencies with this colon notation. So I do text class.py, polarity.train, polarity.test. And then the command, Python text class py train polarity.train test. And just for fun, I'm going to play around with eta, which is the learning rate. So I can run this now, and this will talk to. So this command also talks to CodaLab server directly. So if I go over here and refresh, I'll see that this actually shows up here. So the nice thing about the command line is that it's fairly easy to script. So you can actually write a for loop around this and do a hyperparameter sweep if you want. And you can see, let me refresh. So now notice that there's one thing that's nice is that I can just fire off runs. I don't have to worry about where they're run or manage all the copying around. And CodaLab figures out where to run them on a bunch of workers. You can run things in parallel and so on. So it's a really great way to kind of manage your experiments in a reproducible way. So let me show you another feature of CodaLab, which is notice that each of these runs actually outputs a JSON file. So this is kind of a typical thing that you want to use CodaLab for, is that you output some statistics like the test error. So this is a JSON file that has a field test error. So suppose I wanted to show the test error for each of these runs. Okay, so I can do that by defining a table schema. So I can add a schema here called, let's say, custom. What do I want to show? I can show, let's say, the UID, just the first 8 characters. I can show, let's say, the summary, maybe the state. So I know what state the bundle is in. And I'm now going to show the test error. And here is kind of a cool thing you can do, is remember each bundle has a file called stats.json. So I can reference that file and I can specify a path to the field I want to show, which is test error. So let me just save that for now. So here is my schema. And if I change the schema of this table, I see that now I can customize the view of what I look at. And here I notice the test errors. And maybe I only want to show the first 3 significant figures, and I can just do that as well. So now what's cool about this is that as the models are running, I can kind of monitor any sort of statistics that get output to a file kind of in real time. Okay, so the final thing I want to demo before going back to the slides is the mimic command. So suppose I'm, let's see, so I'm going to now, let's say, modify the features. So I'm going to change the features of this model, right? So let's go to our program. I'm going to go down here, and I'm going to, instead of using unigram features, I'm going to use bigram features. Okay, so I have updated the program locally, right? So I haven't changed this. This version of CodaLab is, sorry, this version of the program is still the old one. So what I have to do is I'm going to upload this new program. And this is just going to be a new bundle now on CodaLab, right? And then, so here's the kind of magic. I can do CL mimic, and just bear with me for a minute. I'll explain what this means. So mimic takes the simple version of mimics 2 arguments. One is the old bundle, and one is a new bundle. So this caret2 notation just means the second to last version of the bundle that's called text class.py, namely this one. And the second argument is the name of the most recent bundle. And what it's going to do is it's going to run whatever I did to this old bundle, I'm going to redo it to the new bundle. So before I ran all these experiments on the old bundle, and now it's saying, just do it all for the new bundle. So this launched 4 runs corresponding to these 4 runs. And if I update the worksheet, I'll see that now I have the set of experiments now for this new bundle. So in one command, I've kind of saved a lot of, you can imagine kind of how much work I've saved, because in one command, I'm just kind of replicating a whole kind of computation graph, so to speak. And this is really useful because, if you had a bug, let's say you run some experiments, you notice a bug in your code, you're just like, oh no, I just need to fix this bug and then redo everything. So that's just one command. Or you have a new data set that has the same format, and you say, okay, I did all this work on this old data set. Now let me just take this new data set, do a one command mimic, and then I have all my results for a new data set. And basically, CodaLab will take care of all the dispatching to the backend. Okay, and now we can see these results and be on your merry way. One thing I'll also kind of quickly mention is if you go to the gallery view here, you can see all the papers that we published and as executable papers, and you can click on one of them, and you see typically a paper has a link to the PDF. It describes, here's the code, here's how I used to get table 2 in the paper, and this uses a custom schema which gives you these results. You can copy this, and you can go to this demo page, and you can paste it. So now you can this is where to go. Okay, it's at the top. So you can actually, one thing that you can is kind of fun to do is you can just grab any sort of experiment that's been run on CodaLab, and you can just rerun it. Actually, you can edit the command if you want and rerun it. So, but I'm just going to rerun it. And the cool thing is that now this, because it's reproducible, this should just like replicate whatever experiment. And this is nice because if you have experiments that you ran, like a year ago or 3 years ago, you don't have to worry about like, oh, how did I run this? Well, it's just, if it's a bundle on CodaLab, you have exactly the provenance used that it's needed to recreate it. Okay, so that is all I have for the demo. Let me go back to the slides and continue. I'm happy to take more questions after the talk. So in the back end, how CodaLab works is that there is a website and also a bundle service. So I showed you a web interface that talks to the website. I also had a command line interface that talks to the bundle service. The website also talks to the bundle service. One thing that's interesting is that I didn't talk a little bit about where the runs are actually happening. It's not happening on the CodaLab server itself because that would slow down the server. Workers actually are, we have a set of workers which are in the back that talk to the bundle service to get jobs to do. But one really cool thing about CodaLab is that workers are client side, which means that you can run a worker on your laptop to CodaLab and you say, hey, I'm a worker, I have free compute, give me some work to do. And CodaLab will happily see if there's any bundles that need to be run, and CodaLab will take care of shuffling things to the worker, getting the results back, and so on. So this allows you to kind of bring your own compute and decentralize compute in a very flexible way. It also means that CodaLab is kind of backend agnostic. You can hook it up to Azure or AWS or GCP. And from the user's perspective, it all is seamless. You just have one way of running commands, and the backend kind of dispatches, which is really nice because it separates like what you want to run from how you want to run it. You can also run your own CodaLab server on your laptop in basically one command, CodaLab service start. If you have, for example, private data that you don't want to upload to the worksheets.codalab.org, which is a public instance. I want to talk through a case study which relates to some of the natural language processing work I do. So question answering is the problem of you're given a passage, you want to answer questions about that passage. And so we created this data set called Squad 5 years ago. And one thing that we did was we hosted a competition where people had to submit their actual code and model onto CodaLab to evaluate on a hidden test set. So initially, it was kind of people started to grumble and say this is a pain, but because it was a standard data, became a standard data set, people were had to do it to play the game. So over time, you see like a huge number of submissions on using CodaLab to support the squad benchmark. So how this worked in the backend, again, use this kind of mimic command. So the idea is that, so people have many different ways of setting up their models. And CodaLab allows you to be very flexible and agnostic to how you want to do it. So we say, go use CodaLab, set up however directory structure you want. All you have to do is you have to take our dev set and produce some predictions and evaluate. And then tell us about it, which is basically tag your model with some special tag. And then what we do, we have a kind of backend script, the competition organizers, that says mimic the dev set with a test set. So this means that whatever you did to get results on the dev set, now I'm just going to swap in the test set and run the same thing. So this ensures that the user has kind of debugged all the kinks and there's no like missing paths or any sort of weird stuff. And we're just going to rerun the thing on the test set. And this works really well because it allows people to have the flexibility of doing whatever setup they want, but also doesn't put any additional burden on us because we're just running one command. So one other kind of cool thing about CodaLab is once all these models were on the site, this was 4 years ago now, we had an inkling that these models were really not understanding language the way that we would want. So we had this adversarial evaluation where we add to a passage a distracting sentence, which has nothing to do with the answer. And you could fool the model into thinking that the answer was something that it wasn't supposed to be. And if you look at the results on CodaLab, so this was a kind of a one-off. So we ran it on one model, BiDAF, but we wanted to do it for all the models to show that this was not just a defect of BiDAF, but something that's more systematic. And fortunately, everything was on CodaLab. So what we did was basically go to all the models, and we just did a mimic of here is the old data set, a test set or dev set rather, and here's the mimic with the new dev set, which is our adversarial evaluation. And then we just ran it and got these numbers. So this is an example of research which wouldn't have been possible without CodaLab, because this just made it, from something that would have taken maybe months to email people, get the code, to something that you could do in a day. Since then, there's been a number of other competitions that have been hosted on CodaLab Worksheets. The confusing thing is that there is also a sister project called CodaLab Competitions, which is it's a separate thing. But I'm talking about CodaLab Worksheets here. So I'll end with a few remarks, and then we have, I think, plenty of time for questions. FAQ. So what programming language can I use? You can use anything you want. CodaLab is designed to be kind of pretty agnostic. It's kind of, you do whatever you want, will get out of your way. So you can run arbitrary Unix style commands in the Docker container. What about compute? So if you go to worksheets.codalab.org, we're hosting a public instance of the CodaLab platform, which is powered by Microsoft Azure. It offers, I guess, some free compute. Obviously, you can't run a lot on it, but it's something to at least allow you to try out things. You can also connect your own worker to the public instance, or you can set up your own installation. So, for example, in the NLP group at Stanford, we have our own CodaLab installation, which is separate from worksheets.codalab.org. How is CodaLab different from Jupyter Notebook? For those of you who a lot of you probably use Jupyter Notebook. Visually, the worksheets are kind of very similar. One thing that's distinct is that in Jupyter, the building blocks are the notebooks, and there's a kind of one kernel in the back that is mutable. So you can get into these kind of weird situations where if you run things in a kind of a different order, then the results might not be reproducible. Whereas in CodaLab, the building blocks are bundles, and there's no kind of global kernel. Everything is kind of localized to a particular bundle, which means that it's more like functional programming and more immutable. So for reproducibility, how is it different from releasing a VM? So VM are just monolithic black boxes, and there's no really sharing that you can do programmatically. One nice thing about CodaLab is that these models and code and data sets are modules that can be composed. So if I have a data set, I put it out, someone else can pre-process it. You can use that pre-processing however they want, or design new pre-processing. People can use the pre-processed data to train models. People can use those models to adapt them to other downstream tasks. People can come with different evaluation metrics. So remember that kind of a graph of the research community doing work. You can actually kind of envision doing that on CodaLab. What about reproducible? Can I just release my code on GitHub? Releasing code on GitHub is great, and we do that as well. But I think it's not the same. Code has unspecified dependencies, and I'm sure many of you probably have downloaded GitHub code, and it's not clear how you run it, or it's missing dependencies. And CodaLab really kind of encapsulates all of these things. So literally, you have a CodaLab executable paper. At the end of it, there's like one figure that is the figure that is in the paper, and you can follow back all the way from the figure to the evaluation to the training to the data set pre-processing to the data set, and you have the full provenance of how individual figures in your paper were generated, which I think is a kind of remarkable level of reproducibility. What's the relationship between CodaLab competitions? As I mentioned before, there's a sister project led by Isabelle Guillon, and you can check that out as well. There's some open challenges. I think in terms of reproducibility at a community level, what's the incentive to upload an executable paper? I think don't have enough incentives in the community for producing kind of reproducible work. And this is something that I hope we can change. CodaLab hopefully can help with this, because at least it provides a mechanism for doing so, hopefully at lower cost. How do you encourage the creation of reusable modules? How do you build a community around CodaLab? And at a productivity level, which is more about the kind of individual, I think one of the challenges we are often face is, how do we give enough flexibility? People do research in different ways, and I think CodaLab captures a pretty good fraction of the research styles, which has to do with iteration and more kind of running batch experiments from the command line. But other people like being in a Jupyter notebook, and that's kind of a different operation. So figuring out how these things interoperate is a challenge. So just to kind of revisit this earlier slide, so we talked about two goals. We want research to be reproducible, which is good for the community, and we want research to be efficient, which is good for individual researchers. And conventionally, think of reproducibility is thought to maybe slow down research, but our claim is that with CodaLab Worksheets, reproducibility can actually accelerate research, because by being reproducible, now things are more kind of tightly integrated in a way that can allow you to, in the long run, kind of benefit you. So I want to thank all the people who have contributed to CodaLab over the years. A lot of engineers and students. The people listed in green are the current development team, and we're always looking for strong developers and people to contribute. So if you're interested, talk to me. And finally, thanks to Microsoft for providing generous support of the CodaLab Worksheets platform. And thank you for your attention.
All right, thanks very much. I don't think we have the ability to do the little hand clap thing in this mode on Zoom, but I'm sure people would be doing that. So I have a ton of questions, but maybe first we can go to the questions that are in the Q&A. I'll just read them out, and then if you want to respond to them. So the first is a bundle in any way analogous to a commit in version control at GitHub?
Yeah, that's a good analogy. One thing that is a bit different is a bundle is self-contained. A Git commit allows you to kind of share information across, for example, a commit could be a kind of incremental patch on top of another commit. But conceptually, yes, I should say the conceptual answer is yes. A commit in GitHub refers to a particular version. A bundle in CodaLab refers to a particular version. The difference is that GitHub, because it doesn't have to worry about compute, I think it allows you to have a finer grain of more efficient storage. But I think the two are kind of compatible at a logical level.
Cool, thanks. Okay, here's another one, which is kind of a fun one. Can this tool help me convince the journal editors and conference organizers in my field to respond reasonably to the fact that almost all the technologies perform far more in proportion to the amount of data used for training than between competing methodologies?
Yeah, so the tool can definitely help you expose and evaluate things kind of fairly. So for example, you can have a competition where you have an evaluation, and you have visibility into what data was used to produce your result. You also have amount of compute that was used. I mean, I didn't mention this, but all the kind of resources used, number of GPUs, how much time it took, how much memory is all recorded. So you have the data there, which could be evidence to form an argument around if you see kind of huge differentials between the best performing method and the amount of data or compute, that could be something. Whereas if it were just a kind of a static leaderboard, maybe a lot of that information would be kind of missed.
Cool, thanks. So just a note to the audience, please feel free to put whatever questions you have in the Q&A. So there's a question about the recording. So the recording will be posted. Franklin, where does the recording actually get posted? Franklin can add a note about that, but basically we will be posting the recording at some point soon. I have a question it's both a CodaLab specific question, but also kind of a more general question about, to get your thoughts about random seeds. What do you do in CodaLab, and then what do you think are the best practices around dealing with random seeds?
Yeah, that's a great question. It's something I'm glad you brought up. I kind of swept it a little bit under the rug. So when I say reproducibility in CodaLab, I should caution that by saying that we are not committed to full reproducibility up to if you have non-determinism in your code, we can't help you basically. Of course, I think best practices are trying to fix the random seed. And make sure that your runs are actually reproducible. And CodaLab makes it easy to check. You just hit mimic, and you see if you get the same result, to kind of stamp out kind of extraneous randomness. On the topic of random seeds, I guess I could answer this from many angles. One is in respect to CodaLab. One is that it's very easy to run random seeds because once you have an existing run, you just swap it out to change, mimic, or rerun with different random seeds. So you can do that fairly easily and try to aggregate the results. I think more broadly, I think random seeds are, I don't know which angle I should answer, but random seeds are good. People should run random seeds and report standard deviations, averages, and so on. Of course, random seeds can also be expensive to run, so that's something that we just have to accept and try our best, I guess.
So in your
there's a
work,
particular angle you had on the.
well, I was just wondering, like in your modeling work, is it standard to look at generalizability across a number of different random seeds?
Yeah, definitely. It certainly depends, and I think being pragmatic about it. For example, if we have a training run that we're able to run multiple times, then definitely random seed over the data ordering or initialization can be helpful. If you're using kind of some sort of pre-training, as is common nowadays, and NLP, which takes many days to run, like a week to run, maybe it would be hard pressed to say like I'm going to do that 5 times. So I guess we just again try to step out as much of the I guess try to vary as much as we can, I suppose.
Cool. So one thing that wasn't clear to me is how debugging would work here. Do you usually like develop the code in an interactive way and then upload it once it's working?
Yeah, that's a great question, and I could give there's another demo I don't have prepared today, but the way that we have set it up is well, okay, let me give you a kind of a more historical answer. Historically, what you would do is you would try to do things locally, but you would set up the environment so that it's kind of isomorphic to all the names and paths match with CodaLab, so you can kind of easily toggle between running things locally and running things on CodaLab. This is what we typically do, so that once things are like compiling and not crashing, then you just flip a switch and now things run on CodaLab. One thing that we've developed as a new feature is to allow this kind of interactive mode. So you do CL run, and you can do -- interactive, which means that it drops you into a Docker container where you can run the command. And then the command might crash, but then you would notice like right away. And you can edit the code, you can rerun, and then and once you're happy, you kind of exit out, and then that actually creates the CodaLab run. So we are moving towards a more integrated kind of modality for the development, so that there's less friction between what you would normally do outside CodaLab and inside CodaLab.
Cool. So I'm wondering how you deal with dependency versions, like library versions. We've seen demonstrations that even like different versions of glibc can give different results on some packages. So it wasn't clear to me how you would deal with that in your system.
Yeah, so let me jump to this slide. So there's kind of 2 types of dependencies. There are bundled dependencies. These are generally reserved for code and data and things that are more interesting, things that you want to focus on. And then there's like versions of glibc and the version of PyTorch or whatever, and these are installed into the Docker image. So when you have a run, you specify the command, but you also specify a Docker image. We provide a default one, but a lot of people just switch to their own custom one because they have custom libraries. And so that's recorded down as like I ran this command in this particular Docker image, and the Docker image tells you what version you're talking about.
And if you try to rerun it, does it get rerun? So let's say I come back 2 years later and I want to rerun it. Does it get rerun in the old Docker image or the current one, or is there a way to specify that?
Yeah, you could specify that. I mean, I could show you how this works. Is this. So here you can say edit rerun, and by default, this is using the old Docker image. But if you don't like that one, you say you have a new version, you can just use a new version. So you have your choice of which one you want.
Nice, cool. Yeah, my other question was going to be about using arbitrary Docker containers, but you've answered that for me. So so that's really nice. Cool. So it looks like there's no other questions in the Q&A. So I guess we can go ahead and thank you again and let you go. And then I'll just remind everybody that we'll be coming back same time next week for a follow-on, which will be kind of a more hands-on type of exercise looking at reproducible modeling. So thanks again, Dr. Liang.
Okay, thank you.
All right, bye, everybody.